All right. So for homework, you had to do some conversions, right? So the first three were degree angles that you had to convert to radians, and then you had some radians that you had to convert to degrees. So let's go over those. So the first three, remember, when we're going from degrees to radians, our radians, we'd like to have pi in there, okay? Now, I do want to make a disclaimer. You won't always have pi if we're talking about radians. Okay, if somebody just says 1 radian, okay, that's possible, right? And we went over that yesterday. We know 1 radian would be equal in length to whatever the radius is, right? Or it would be the angle that you rotate, I should say, right? So don't be surprised if you see, 2.4 radians and you don't see a pi there. Okay, it's not necessarily always there. But when we're converting from degrees to radians, okay, your answer more than likely will always have a pi in it. So in order to do that, okay, I'm going to take the 120 and I'm going to multiply it by pi over 180. Right? So then I have, well, 120 pi over 180. Right? But that is not reduced form. We want to reduce that. Well, I can get rid of a 0, and I can divide them both by 6. So 120 degrees would be 2 pi over 3 radians. All right. And I think I mentioned this yesterday. Normally, we tie in the pi with the numerator, but if you wrote two-thirds pi radians like that, okay, that is also acceptable. All right, just as long as the pi is not in the denominator for now. Okay, so that is the answer to number 1, 2 pi over 3. For 45, okay, we're worried about reducing 45 over 180. I know I can divide them both by 5. That would give me 9 pi over 18. No, that's not right. 180 divided by 5 is... it's too early. I didn't have enough coffee this morning. Yeah, 36. Okay, I can divide both of those by 9. And we get pi over 6. Okay, or again, if you wrote it differently, 1/6 pi. Right, but we like this. It's a little neater than writing that. Now the third one. I didn't technically go over a negative one yesterday, but the negative just tags along for the ride, right? If it's negative degrees, of course, it's going to be negative radians. So we apply the same concept. We multiply by pi over 180. So I'm worried about simplifying 210 over 180, and that negative comes along with it. All right, so I can divide by 10. 21 and 18, 3 goes into both of those. So I have 7 pi over 6 radians. All right, any questions about the first 3, converting from radian degrees to radians? All right, so the rest of them, we're going from radians to degrees. All right, so remember, we need to get rid of the pi now. So pi is going to be in our denominator when we multiply. All right, so pi over 3, we multiply by 180 over pi. The pi's eliminate. I have 180 times 1/3, or 180 divided by 3, and that gets us 60 degrees. All right, so pi over 3 is equal to 60 degrees. 7 pi over 4. Okay, again, we multiply by 180 over pi. 180 divided by 4 gets me 45. 45 times 7 gets us 315 degrees. Okay, or if you have, a good calculator where you can enter fractions and stuff, you could just type in 7/4 times 180 and you get 315. Okay, I just like to do it this way just because sometimes it's, you can do it in your head where you just divide like that. All right, divide and then multiply. And then 7 pi over 12. All right, we multiply by 180 over pi. 180 divided by 12, I believe, is 15, I want to say. Yep, 15. And then 15 times 7 gets us 105. All right, so there we have our 3 conversions from radians to degrees. Any questions? Okay, so we'll see how much time we have today. But first, I want to revisit something we briefly talked about, I think, yesterday. If not yesterday, then Monday. And that's coterminal angles. All right, so just a refresher. Okay, coterminal angles are 2 angles with different measurements that end up sharing the same terminal side. So they kind of end up being the same angle. All right. So the example that we saw, right, if we're looking at our standard angles, if I mapped out, I think it was 330 degrees, right? So here would be our initial side. I would measure out 330 degrees, and that would put me over here in the 4th quadrant. And this would be 330 degrees, right? So remember, we go clockwise around. Usually we show the angle by starting an arrow on your initial side and drawing it circular, ending up at the terminal side. Okay, we also found out that if we travel in the opposite direction, if I travel clockwise, okay, that gives us a negative angle, right? So negative 30 degrees, if I start up here, would put me down here, and they would be coterminal angles. Okay, both of those measurements, we would end up in the same spot if we're looking at angles in the standard position. So you may be asked to find a coterminal angle, and it's pretty simple. Okay, we use the fact that one full rotation is 360 degrees. Okay, or if we're talking about radians, which we will be doing, 2 pi radians. So in order to find a coterminal angle, okay, we just have to do a rotation, right? That's kind of what we did for that other example, but it's a little different because we did negative, right? So we go in the opposite direction. All right, so say we want to find an angle that is coterminal with 150 degrees. All right, so just to map it out, right, remember we talked about our quadrants. 150 degrees would be in our second quadrant. So there's my initial angle, and then I would be somewhere around here. It's not going to be perfect. I don't have a protractor to measure it. I know that up here is 90 degrees, remember, and over here is 180. So maybe it should be a little closer to this line, to the x-axis, but we're just sketching a graph, so it doesn't have to be perfect. So I can do one of two things here. I can continue the rotation. So I can come from here and keep continuing and end up in the same spot. To do that, okay, we would add one rotation. So we would add 360 degrees. Okay. So by adding 360 degrees, we end up in whatever spot we left off because 360 degrees is one rotation. Let me put the degree sign there. Did I do this right? 4, right? Okay, so 150 degrees and 510 degrees are coterminal angles. I could keep adding 360 and find an infinite amount of coterminal angles, okay? We could also travel in the other direction. I can subtract 360 degrees, right? So if I start here and I go clockwise now, 360 degrees, I again end up in the same position. I'm sorry, it's a lot of swirly lines here. So I could also do 150 degrees minus 360. And that gives us negative 210 degrees. So just because it's looking a little sloppy, if I did negative 210 degrees, okay, I would start here and I would travel negative in my, in my rotation. So this would be negative 90 degrees here. This would be negative 180 degrees. And then, so negative 210 would be somewhere in between here and here. So we'd end up with the same spot. Okay, so when we are in degrees, it's super simple. Add 360 or subtract 360. Now, if we're talking about radians, it's also pretty simple, but we just got to be careful because radians, we're usually dealing with fractions. Okay, so let's take a look at one of those. So I want to find a coterminal angle to 2 pi over 3. 1 second, let me just check something on when I told you about the quadrants. Didn't I tell you about quadrants? Did we go over quadrants? I feel like we did. I'll do it again in a little bit. All right, so we want to find a coterminal angle to 2 pi over 3 radians. Now, one thing you could do is you can convert it to degrees and then add or subtract 360. But with that, if the problem you're given to is in radians, then your answer should also be in radians. All right, so then you would have to convert again. Now, that's not necessarily, rocket science. It's not the hardest operation, but that's doing a lot, right? Going to degrees, adding, subtracting, going back, right? So we can apply the same concept. We can add or subtract 1 full rotation, but now 1 full rotation is 2 pi. So I have 2 pi over 3 plus 2 pi. So we're adding fractions. We need our common denominators, right? So the 2 pi over 3 is going to stay 2 pi over 3. 2 pi becomes 6 pi over 3, right? Because here I have 2 pi over 1. I multiply this numerator and denominator by 3. And then I add. The pi just kind of tags along for the ride. We don't touch that. That stays the same. And I have 8 pi over 3 as my coterminal angle. Okay. Again, we could also subtract 2 pi. All right, just be careful here with your signs, your positives and negatives. All right. So when we subtract 2 pi over 3 minus 2 pi, that'll get us 4 pi over 3. Right. So all of these 3 angles, 2 pi over 3, 8 pi over 3, and negative 4 pi over 3, all end up in the same spot. All right, any questions there? All right, so real quick, I just want to revisit our quadrants. I think I did it on the whiteboard in one of the lessons. But now that we know both degrees and radians, okay, I want to solidify what we have. So again, here, this line here is 0 degrees, 0 radians, whatever, what have you. Okay, up here would be 90 degrees or pi over 2. So we have any angles in this quadrant, okay, are going to be from 0 to 90 degrees or from 0 to pi over 2 radians. All right, remember 90 degrees is pi over 2 radians. That's our conversion. Over here, okay, our angles go from 90 to 180. Okay, or if we're talking about radians, it goes from pi over 2 to pi. Okay, again, this is quadrant 1. This is quadrant 2. Down here, okay, we go past 180. So our angle is from in between 180 and 270, right? That would be another 90 degrees from 180. Or in radians, it would be pi to 3 pi over 2. Okay, that would be quadrant 3. And then our last quadrant would be from 270 degrees to 360 degrees, or from 3 pi over 2 to 2 pi. And that's, oh man, my pencil keeps breaking. That is quadrant 4. All right, so you could probably find this online somewhere if you ever need a quick, recap and you forget your quadrants. All right, you can just look up quadrant angles online. All right. What do we got? 7 minutes. Okay. So I'm going to talk about something real quick. Actually, so we won't get into arc length today. We'll do that tomorrow. But I want to revisit a geometry topic. Okay, complementary and supplementary angles. So it's probably been a little while since you've seen these. Sorry, there's some noises outside. Okay, so let's remember what they are. Okay, our complementary angles are usually two or more angles that add up to 90 degrees. Okay, and supplementary angles add up to 180. Now, honestly, probably the one of the more difficult parts is to remember which one's which. All right, so I don't know if you learned a method in geometry, but I have two that I like to use. The first is alphabetically, complementary comes before supplementary. 90 comes before 80, so it fits that way. Okay, the other way is if you look at the first letters, complementary, I can make the C into 90 degrees. Supplementary, I can make the S to 180 degrees. All right, so if you're ever stuck and you don't remember which one's which, all right, you have a few different ways to remind yourself, some pneumatic devices. All right, so the C for 90 and the S for 180. So if we're talking about degree measurements, it's not too difficult, right? If you want to find a complementary angle to 40 degrees, you just know that you have to add 50. So just be careful if we're talking about radians. All right, 90 degrees in radians is pi over 2, and then 180 is pi. So if we're looking for complementary and some supplementary angles with radians, all right, you just have to use pi over 2 and pi instead of the 90 and 180. So real quick, the last few minutes, we're going to find the complementary and supplementary angles to 2 pi over 5. All right, so this is going to be less than 90, and obviously it's going to be less than 180. So for each one, all we have to do is subtract this from whatever we have. So for complementary, we're going to do pi over 2 minus 2 pi over 5. So again, just be careful with common denominators. Here our common denominator would be 10. All right, so I'd have 5 pi minus 10 minus 4 pi over 10. So pi over 10 would be my my complementary angle to pi over 2. I'm sorry, to 2 pi over 5. Okay, and then for supplementary, we do the same thing, but now I'm just subtracting it from pi. Okay, be careful. Our pi over 2 or our pi have to come first. Right? Otherwise, you'll end up with a negative answer. So here we get 3 pi over 5 would be the supplementary angle. Okay. Now, in all honesty, we're not going to see this pop up too much. All right, but it is good to know how to do that quickly when we move forward with some more tricky stuff, when we actually start talking about trigonometry, sine, cosine, all that stuff. All right. Any questions?